So it has serious spurs coming from the LOs. So we have seen that. So since you have two LOs, the spurs are going to cause a serious issue. And the spurs, since we are operating at omega 1 by 2, the spurs can create replicas of the signal at omega 1 by 2, 3 omega 1 by 2, and 5 omega 1 by 2, which will lead to the envelope of signal being asymmetrical. So you can see how the signal is asymmetrical over the frequencies from minus omega 1 by 2 to plus omega 1 by 2. This is the IF output, and after modulating with RF, this is going to be the output. And the RF, we are going to give the frequency omega 1 by 2. Okay, so one set will be having omega 1 by 2, and other set will be having 3 omega 1 by 2. So two low frequencies we have, and it is an asymmetric spectrum. It is not an even spectrum as you see. And if you take a mirror image at 0, here I have 4 components, but here I have 2. If you take mirror image of the below portion, here I have 2, but here I have 4. So the input IF is symmetric, but because of mixing spur happening at minus 3 omega 1 by 2, minus omega 1 by 2, omega 1 by 2, 3 omega 1 by 2, all the odd components of omega 1 by 2, we are going to have an asymmetric spectrum where at the receiver detection is going to become very, very difficult. In other words, the amplitude you see, it is reducing. The amplitude is also reducing as the spur increases. So upon mixing with second IO, they are again shifted by an equal amount. So interestingly, you can see the different replicas are happening at odd multiples of omega 1 by 2. So unwanted sidebands at omega 1 by 2, 5 omega 1 by 2, 7 omega 1 by 2 have to be suppressed. For that, you need to have a separate filter. So you can see how, so if you think about solving one problem, it is going to lead to another problem in the architecture. It is going to be a very serious issue. So similarly, this value, the level of corruption is minus 20 dB. So the signal is corrupted by minus 20 dB, which is a very large number. But this is acceptable only for modulation schemes requiring a moderate SNR. And the error rate is also very poor. But if you require a system that is going to have a very decent BR of 10 power minus 6 or 10 power minus 7, then this level of corruption is not good, and it has to be close to 0. It has to be close to 0. So we need to we need to introduce some IF filtering to suppress the unwanted sidebands before you convert them into RF signal and transmit. So once the signal goes to antenna, you cannot do anything. So before the signal goes to power amplifier, we have to do all possible mathematics to ensure that the signal is free from unwanted